right, so today we're starting section 2.4 called the chain rule. And this is a new technique that you guys can use to find derivatives. We've talked about the product rule, we talked about the quotient rule. Today we're going to talk about this cool thing called the chain rule. Well, maybe it's not cool, but we'll see. So, first of all, you use the chain rule, and I told you guys that you didn't have to write this part down, but you use the chain rule when you have a composite function. And you might be thinking, what is a composite function? You did learn what a composite function was last year. I can't find my tools. Sorry, guys. Okay. You learned about what a composite function was last year, and all a composite function is that you have a function inside of another function. So, in other words, do you remember seeing it like this? Composite functions, f of g of x. You had like g of x that was kind of hidden inside of f of x. It was very, very early in pre-calc. I think it's in chapter 1, maybe even in chapter 1. An example, if f of x is equal to x cubed, g of x is equal to 2x squared plus 7x, f of g of x, the composite function, meant that you figured out the value of f of x when you replaced the x value with g of x, 2x squared plus 7x. Don't dwell on this too much. If this was foggy to you then, this is not the goal of this unit. The goal of this unit, well, not this unit, but this section is, I will get to that in just a minute. But really what you're doing is you're taking this x value, 2x squared plus 7x, and you are plugging it into that x value right there. So you have some function cubed. So if I asked you to figure out what is the derivative of 2x squared plus 7x to the third power, what would you do? Oh, okay. Wow. If I asked you to find the derivative, one of the things that you could do is actually write 2x squared plus 7x out 3 times. You could multiply all of them together, which would end up being a horrendously long polynomial. You'd have to reduce it, and then you would find the derivative of each thing. But that's very, very tedious. There's a much easier way to do this, and the rule of the shortcut that I'm going to show you is to use the chain rule. All right? So, an example, or what the chain rule means, I should say, is this. I asked that question, how would you find the derivative of 2x squared plus 7x to the third power? There are ways of doing it. You certainly could, you could even use the product rule too to figure out the derivative of that thing, but there's shorter ways, which is why I'm going to show you guys how to use the chain rule. The chain rule says this, and when I explain this to you, it's going to be confusing. It will make more sense after I show you with some examples. So, let's say you have some function, h of x, is equal to f of g of x. In other words, you have a composite function, and I ask you to find the derivative of that composite function. This is what you need to do according to the chain rule. You take this function, g of x, and you call it u. So I went over here to the side. You're going to do lots of side calculations when you're using the chain rule. You go over to the side and you call g of x u. You also are going to need to know the derivative of g of x. Now usually g of x is something very, very nice, a very easy polynomial to find the derivative of. So you write down what u is. U is the function that's hidden inside of the other function. You find the derivative of it. So u is the function. U prime, the derivative of u, is the derivative of g of x. And you rename f of g of x. You rename this by calling it f of u. Are you okay with why I'm calling it f of u? Why am I putting a u here instead of a g of x? Because over here I said u is g of x. All right, so now the derivative, according to the chain rule, this right here is the guts of it right here. You might want to paint a big old box around this. The derivative of h of x is equal to the derivative of u, derivative of f of u, get it? F of u. And you multiply that by the derivative of u. That will get you the derivative of the function, of the composite function that you're working with. So some of you are going, I have no idea what she just said to me, which is normal. I'm going to show you with an example, and hopefully you'll be okay with this. So, yes?
Okay, so your derivative of u, this is like equals g of x. Where does that come in?
You are, after you find the derivative of u, then you are going to multiply it by the derivative of whatever it is that you went over here and called u.
Okay.
So typically, u is going to be just an easy polynomial. In this example right here, it's going to be a nice, easy, they'll get harder, but for starters, they're going to be an easy polynomial. And then when you find the derivative of it, that's a piece of cake. Find the derivative of an easy polynomial is a piece of cake. So, an example, f of x is equal to 2x squared plus 7x cubed. Do you have this in your notes? Okay, 2x squared plus 7x to the third power. All right. Do you see a function hidden inside of another function? This, in other words, what that means, you guys, is that do you have some function put to a power? Do you have a function put to a power? Yes, you have 2x squared plus 7x put to a power. This is the thing that you're going to go over to the side and call u. And right off the bat, this is what you should do. Name u. U is 2x squared plus 7x. The derivative of u. What is the derivative of 2x squared?
4.
It's 4x. What is the derivative of 7x?
7.
It's 7. So u is what we're going to call 2x squared plus 7x. In other words, it is the function that's hidden inside of another function. The derivative of that is a nice, quick, easy 4x plus 7. According to the chain rule, to find the derivative, you do this. Whatever you called u, you write down u. 2x, you write down, instead of writing down 2x squared plus 7x, you write down u. But u is being put to the third power. So you write u cubed. All right, so notice so far I've said f of x equals 2x squared plus 7x cubed. All I have done is replaced 2x squared plus 7x with a u. I have not started taking the derivative yet. We're going to start taking the derivative now. According to the chain rule, you find the derivative of f of u. What is the derivative of u cubed?
3.
It is 3u squared. 3 times u squared. And then, according to the chain rule, you have to multiply that by the derivative of u. So in other words, I just wrote down u prime. U, derivative of u is called u prime. I haven't done anything with it yet. But the next thing I'm going to do now is substitute. I'm going to write down 3u squared. Here's your 3. U is 2x squared plus 7x, so I write that down. And I put it to the second power. In other words, I am just substituting back in the u with what I called u to begin with. And then I multiply it by the derivative of u, which is 4x plus 7. And that's it. That's it. Now, you could go through and FOIL this and then distribute a 4x plus 7 in it, but why? Remember, this is what you would use to find the slope of a tangent line, and you would take an x value and you'd plug it in. It doesn't matter how it looks, you're still going to get the same answer. So there would be no need necessarily to actually FOIL and then distribute.
Wait, can you explain the
Yes.
last step one more time?
Okay, so according to the chain rule, you need to find the derivative of u. So whatever you called, you need to find the derivative of this. It's u cubed. So what is the derivative of u cubed? It's 3u squared. So I wrote down 3u squared. And then you have to multiply 3u squared by the derivative of u. Well, you said that u is 2x squared plus 7x. The derivative of that is 4x plus 7. You're okay with that, right? 4x plus 7. All right, so I wrote down 3u squared times u prime. But then I took these u's and I rewrote them, just replacing u with what u is and I replaced u prime with what, the derivative of u was, 4x plus 7 in this case. Yes?
So since you said we can just plug something for x, can't you just do that for the top one too?
For the top one, too.
2x squared plus 7x cubed.
Yeah, but this is the function, it's not the derivative yet. That's the original function. You'd have to find the derivative first. The derivative is what gets you the slope of the tangent line. So then if I gave you an x value, plugging it back in here isn't going to get you the slope of the tangent line. It's just going to get you the y value at that given x value of whatever that function looks like. It's not going to get you the slope of the tangent line. Okay, let's go on to another one. I have another 3 more examples, I think, for you guys to work on. We're going to work on together. I wish now that I had not written this one out, we could work on it together. But the next one I did leave blank, so we'll work on it together. All right. The first thing you need to do is look for you need to look for the function that's trapped inside of another function. So what is the function that's trapped inside of another function?
4x.
3x.
I was gonna have the other one.
3x minus 2x squared. Are you okay with identifying that?
Mm-hmm.
I don't think that part's too bad. So this is the function that's trapped inside of another function. So what are we going to call this? 3x minus 2x squared. Go over here to the side. We're going to call it u. So u is 3x minus 2x squared. Quickly find the derivative of 3x minus 2x squared. The derivative of 3x is 3. And the derivative of 2x squared is negative 4x. Probably not a big deal, but you want to do that right away. You're always going to have to do that. You're going to have to identify u, and you're going to have to find u prime. All right, now the next thing that you need to do is, since we called this 3x minus 2x squared, since we called it u, I'm just going to call h of x, instead of calling it 3x minus 2x squared cubed, I'm just going to call it u cubed instead. And now I'm going to start applying the chain rule. And the chain rule says that you find the derivative of this. You find the derivative of u cubed. What is the derivative of u cubed? The derivative of u cubed is 3u squared. And then you have to multiply that by the derivative of u. So, you've got this on your paper, hopefully. Now you just go through and you start substituting things. So I'm going to write down my 3. What is u? Well, u is what we started with, 3x minus 2x squared. So I'm replacing this u with what it is. I put it to the second power, and then I have to multiply it by the derivative of u. Well, the derivative of u we said was 3 minus 4x. We're done. That's it. Let's try this one together. Notice, I gave you the function, I went over to the side, I said, what's u prime? So let's do it. What is u?
4x.
4x.
It is 4x cubed minus 5x. What is u prime?
12x squared minus 5.
12x squared minus 5. Going to need those, may as well go to the side and do them right now. So now what I'm going to do is rewrite f of x. F of x is going to be equal to, instead of writing all this stuff right here, I'm going to replace it with what? U. Yes, I'm going to write u to the 4th power. But according to the chain rule, to find the derivative of such a situation, you have to do what? You find the derivative of u to the 4th. What is the derivative of u to the 4th? 4u cubed. The next thing that you need to do is multiply this then by u prime. In other words, the derivative of u. Now you just go in and substitute things. So this is going to be equal to 4 times u,
4x cubed minus 5x.
which is 4x cubed minus 5x to the power of 3. And then I have to multiply that by the derivative of u,
12x squared.
which is 12x squared. I forgot my x. 12x squared minus 5.
We don't have to do that.
Don't have to do the math. There will be times when you do, but I will point you in the right direction there. Okay? Are you okay with this?
Yeah.
It's actually kind of fun.
No.
Okay, no, I'm just joking.
Okay.
Another example. Did I tell you that they were going to get a little bit harder?
Yeah.
Oh, I didn't? Okay, sorry. I forgot to tell you that. Okay, so here we go. G of x is equal to the cubed root of x squared minus 1 to the power of 2. X squared minus 1 squared. So the first thing that I want to do, I got to get rid of that cube root. I got to get rid of that cube root symbol. And I'm going to get rid of the cube root symbol by writing it not as the cubed root, but as writing it as the 1/3 power. So what I did was I took this x squared minus 1, I put it to the second power just as it is in the problem, but then I put an extra set of parentheses around it, and I raised it to the 1/3 power. So now I need to take you back to, I don't know, maybe Algebra 1. I can't remember when it was that you guys were originally introduced to this. But you were taught that if you had x, say, to the second power, to the third power, what did that mean? It was x to the sixth power. And the reason it is because x squared cubed means x squared times x squared times x squared. Well, x squared times x squared times x squared is x to the power of 6. So in other words, you're just multiplying those two. 2 times 3 is 6. Do the same thing here. Multiply the exponents. So really what you have going on here is x squared minus 1 to what power? What is 2 times 1/3? You guys. 2 times 1/3 is 2/3.
Oh my gosh, really?
Okay. 2/3 power. 2 times 1/3 is 2/3. It looks much nicer now. We have an expression to a power. What's u? It's the thing that is put to a power. So u is x squared minus 1. What is the derivative of u? In other words, u prime. It is 2x. Valuable information over there. Now I'm going to go back to my problem. I am going to rewrite g of x. No longer will I write it as x squared minus 1 to the 2/3 power. Instead, I will write it as u to the 2/3 power. U to the 2/3 power. I have not begun to find my derivative yet. I have only rewritten my expressions. So now, to find the derivative using the chain rule, it tells us that we have to find the derivative of u. So what is the derivative of u to the 2/3 power? I sound like a bad boy right now. 2/3 u to the what power?
Negative 1/3.
Negative 1/3. Yeah, so 2/3 minus 1 is negative 1/3 power. But then we need to multiply that by the derivative of u. So I'm just going to write u prime right now. And now I'm going to go back and I'm going to substitute everything in. So this is equal to 2/3. What is u?
X squared minus
X squared minus 1 to the negative 1/3 power, and then I need to multiply that by 2x. Alright, now this, we need to clean up a little bit. Easy to clean up, we've got a negative exponent, we gotta get rid of that, so we have to take this a step further. So first of all of these things are being multiplied. The 2/3 is being multiplied by x squared minus 1 to the negative 1/3 power, and that's being multiplied by 2x. So my suggestion would be to multiply 2/3 times 2x. What is 2/3 times 2x?
4/3.
Remember, this is 2x over 1. Yes, we're going to multiply the numerator 2 from 2/3 times 2x. So we're going to have 4x over, and then you multiply the denominators. 3 times 1 is 3. So we really have 4x over 3. But then we have this x squared minus 1 to the negative 1/3 power. We can't leave it like that. So instead I'm going to move it to the denominator. So we're going to have 4x on the top, and then on the bottom we're going to have 3 times x squared minus 1 to the power of a positive 1/3. Now your clue there that you could clean it up is that we had some pretty easy things to multiply. 2/3 and 2x, those will multiply nicely. And then of course you can't leave negative exponents, so that's a clue, you gotta move it to the bottom. Okay? Okay, all right. One more example, and then I'm gonna shut up for the hour. No comments from any of you. Okay. G of x is equal to negative 7 times 2x minus 3 to the second power. All right. Do you see what I did? First of all, I changed this 2x minus 3 to the second power. I changed it by moving it to the top. And I made it a negative 2 power. You okay with that? That should be old hat. That shouldn't be a big deal to This was the original expression. I just took this 2x minus 3 squared and I moved it to the top. And when I move it to the top, I have to change the exponent to the opposite of what it was. So it went from a positive 2 to a negative 2.
Why did you do that?
Well, in order, it's going to be easier to, otherwise right now, we have a division problem, and we're going to have to go and use the quotient rule. And if you can avoid using the quotient rule, avoid using the quotient, because in this case, you would have the product rule, you'd have the quotient rule inside of the product rule. Avoid that if you can. There are going to be times when you can't avoid it, but for right now, if you can avoid having to deal with this fraction and using the quotient rule, then by all means do it. And that's just a quick, easy fix. Move it to the top, change the exponent to the opposite. All right, what's u? 2x minus 3. So u is 2x minus 3. What is the derivative of u?
2.
It is 2. Derivative is 2. All right. All right. Now what I'm going to do is rewrite this. And when I rewrite it, I'm not finding the derivative yet. I'm just rewriting it in terms of u. So I'm going to write negative 7. Instead of writing 2x minus 3, I'm going to write u. But that has to be to the negative 2 power. All right. I'm done rewriting now. Now I just need to apply my chain rule. And the chain rule says that you find the derivative of g of x. What's the derivative of negative 7u to the negative 2 power? 14u to the negative 3 power, right? Negative 2 minus 1. And then we have to multiply that by the derivative of u. So I'm going to write times u prime here. All right. Now we have to substitute things here. So we have a 14. Replace u with what it is. And it's 2x minus 3 to the power of negative 3. And we multiply that by 2. Which is equal to. Clean it up, you guys. We've got a 14 out front. We have a 2 at the end. What does that give you?
28.
28. multiplied by 2x minus 3 to the power of negative 3.
28 over 2x minus 3 to the power of 3.
Excellent. 28. Move the 2x minus 3
Back to the bottom.
to the bottom, change the power, so we have a positive 3. How do you guys feel?
Okay.
Eh?
Homework.
It's easy.
What time is this supposed to be on?
Oh, just